we're going to continue doing some examples for the log rules for integration. What I find in this particular case is that practice makes perfect. Just got to keep on keeping on. So let's get started. What I have is 1 over 4 minus 9x dx. So in this particular case, what I'm going to do is I'm going to perform a substitution. You start off just kind of looking in the denominator and say, okay, 1 over 4 minus 9x. Then let's try u equals that. Let's say u equals 4 minus 9x. So that tells me that du is negative 9 dx. Because we'll take a derivative, that'll go to 0. The derivative of negative 9x is negative 9. Which tells me that negative 1/9 du equals dx. Okay? So then I now have something to substitute for that, and I have something to substitute for dx, which gets me 1 over u times negative 1/9 du. So then I can pull out the negative 1/9. I can say negative 1/9 1 over u du, which is negative 1/9 natural log of u plus c, which is negative 1/9 natural log 4 minus 9x plus c. Okay, that's our first piece. Now let's move to the problem number 2. I have x cubed over x to the 4th plus 1. So there's kind of a neat piece here. What you're going to find is that if you have a polynomial where the degree on bottom is 1 greater than the degree on top, generally speaking, you can use log rules to get you there. It may not be as easy as just take u to this and du is that. It doesn't always work out that well. But it's at least a good start. So if I take u to be x to the 4th plus 1, then I know that du is 4x cubed dx. So then I have an x cubed and I have a dx. So then I could say 1/4 du is x cubed dx. Okay, so that replaces those two pieces, and that replaces that piece. So I now have 1 over u times 1/4 du. So then I can pull the 1/4 out front. And by taking the antiderivative, I get 1/4 natural log of the absolute value of u plus c, which is 1/4 the natural log of x to the 4th plus 1 plus c. Now in this particular case, we don't need absolute value because x to the 4th plus 1 is always a positive, always has positive magnitude, or not magnitude, but is always a positive number. So you can leave the absolute value on there, but it's redundant. Okay, so the next piece we want to do is this one. So we're going to follow the same process. But now, we have, it's a little more complicated, but it's going to be all right. We're going to let u be x cubed plus 8x. And then du is going to be 3x squared plus 8 dx, which is very convenient. It basically absorbs everything into this. That gets us 1 over u du natural log of the absolute value of x cubed plus 8x plus c. So that was mind-numbingly easy. But hey, I'll take wins wherever you can get them, right? This one's going to be a little more complicated. This one's going to involve not only log rules, but one of the previous topics we've discussed, which is being a little bit more clever with our substitution. So again, you may say, okay, well, I see this is in the denominator. Should I pick x minus 5 squared as my choice? And that you could do that. I wouldn't recommend that. Generally speaking, just pick what's in the parentheses. But then that's going to, you may be thinking ahead, but just trust me for right now. So we're going to say u equals x minus 5. So du equals dx. Alright, so if that's true, this becomes u squared, and that'll become du. But what happens to 8x? I don't really have anything here. So we have to use that sort of clever substitution where we say, well, if u is x minus 5, then x must be u plus 5. Oh, okay, alright. So then I now have 8 times u plus 5 over u squared du. So from here, what we need to do is, let's go ahead and pull that 8 out front. Alright, so in this case, alright, u plus 5 over u squared. That's not that helpful, so let's split that up into two separate fractions. We're going to get 8 u over u squared plus 5 over u squared du. Okay, then what we're going to do is, let's simplify this a little bit. Okay, then we're going to separate this into two separate integrals. We're going to say that's 8, 1 over u du, plus, and we'll go ahead and pull that 5 out too while we're at it. We'll call that 40, 1 over u squared du. So this one we know, this follows the log rule. It's 8 natural log of u. I won't worry about my plus c yet. But for this one, 1 over u squared, well, that's not a log rule. That's a general power rule. That's like u to the negative 2. So we add 1 to the power to get u to the negative 1, and then divide by the new power. So that's u to the negative 1 over 1. But what that really means is that's negative 40 over u. And there's your arbitrary constant. So then what we have to do is we have u's, we need to go back to x's. So we're going to say that's 8 times the natural log of the absolute value of x minus 5 minus 40 over the absolute value of x minus 5 plus an arbitrary constant. So that's a little tricky, but that's kind of the way it goes sometimes.